Good morning. This lesson is for my Trig-Precalc class. This is lesson 1 for section 7.3. Before I get started, I want to say I hope everyone's doing okay out there. And I want to encourage you guys. We got a couple more weeks left. Let's do everything we need to do to put ourselves in a position to pass. Again, everybody in my trig class, you guys can all pass. Just do the work. Do everything I asked you to do, and you will pass. All right, so let's just jump right into our lesson. And I have to be honest with you, this is the 4th time I've tried this. And the reason why it's my 4th time. First time, Thursday knocked over my camera. The second and the third time, I wrote the equation wrong. And boy, oh boy, does that make things not more difficult. For these problems, I don't want you to have fractional answers. And since I lost a minus sign here the second attempt and lost a minus sign here my third attempt, I was getting fractional answers. I don't want to do that to you guys. I want you to have nice, simple problems to begin with, and then we can build off of that. So let me talk about what we're doing here. Okay, so we're going to solve the 3-variable system using Gaussian elimination. Remember, Gauss showed us that we can add equations together. When we add them together, we get a new equation. And that new equation is what we would call an equivalent equation because it will have a same answer as the 2 previous equations. So that's why why we're allowed to do this. A couple other things that are really important to note. These 3 equations can be moved. I can put this one on the bottom, this one in the middle, and this one on the top. It doesn't matter. I can move them anywhere I want, the entire equation. All right, you have that option. I like this equation where it is. These 2, doesn't matter. This one's great where it is because the number with the x value is 1, and that's a very easy number to use when we're talking about Gaussian elimination, right? You saw that we can multiply an equation, and it's very, very simple to use. The second important thing that I want to note is that when this is all said and done, one equation of the 3 will have all the variables. The second equation will have the 2 variables y and z, and the last equation will only have a z. Our answer is now what's called an ordered triple. Not an ordered pair, an ordered triple, because now we have 3 unknowns, an x, a y, and a z, so we have an ordered triple. All right, so I guess let's just jump right in. You'll see it's pretty simple. I wanna introduce these with the easy problems, okay? All right, so this is just, adding equations together and getting variables to cancel. Off to the side, I'm going to write down what I'm doing. Okay, this is my row 1, this is my row 2, this is my row 3. Again, I like this row 1 because I can use this to cancel this and this, and I'll show you how I do that. All right, so what I'm going to do is I'm going to take my row 1, which is that. I'm going to add it to my row 2, and now I'm going to have a new row 2. So I'm going to write down below my system again. I'm not doing anything in the first equation. I like this first equation. It's got 3 variables. And I'm just going to leave that as my first equation. So I have my 1x minus my 2y plus my 3z is equal to 9. Alright, so now let's do this, because remember we're going to replace our existing row 2 with a new row 2 after we add row 1 to it. So I'm going to add these 2 equations together like Gauss showed us we can do. 1x minus x, there's no more x's. Minus 2y plus 3y, that becomes 1y. Plus 3z plus z, that's going to give me 4z's. And 9 minus 2, that's going to give me a 7. Alright, so now I have my new row 2. Now I'm going to use my row 1 to get rid of that x in my row 3. I need this to turn into a negative 2, right? So what I'm going to do is I'm going to take negative 2, and I'm going to multiply my entire row 1 by it, and then I'm going to add that to my row 3, and that becomes my new row 3. Alright, so let's see here. So if I multiply this by negative 2 and I add it to this, it goes away. If I multiply this by negative 2, it becomes 4y. Positive, right? Negative, negative makes a positive. 4y minus 5y, that's going to be minus 1y. Alright, so let's see here. Negative 2 times 3 is negative 6z plus 5z. That's going to be negative 1z. And negative 2 times 9 is negative 18. Negative 18 plus 17, that's negative 1. Alright, so I took negative 2 times my row 1, I added it to my row 3, and that's my new row 3. I have one equation with all 3 variables. I have one equation with 2 variables, and I'm going to get to one equation with one variable. So what I'm going to do is I'm just going to add row 2 and 3 together, because they're going to automatically make the y's cancel. So here I take row 2, and then I'm going to add that to my row 3, and this is going to become my new row 3. So let me write what I'm going to keep. So it's 1x minus 2y plus 3z. That's equal 9. Row 1 didn't change. I like row 2. That's good. It's got 2 variables in it. 1y plus 4z, and that's equal to 7. Alright. And let's see here. So let's do this. Row 2 and row 3 together. Row 2, so 1y minus 1y, there's no y's. 4z minus 1z, that's 3z. And 7 minus 1, that's 6. This is exactly what I wanted, right? I wanted one equation to have all 3 variables. I wanted the next equation to have 2 variables. I wanted my last equation to have 1 variable. Because now I can solve, right? I can figure out what z is, and then plug that in here and figure out what y is. And then once I know what y and z are, I can plug that into here and figure out what x is. So let's finish this. Alright, so z in this situation is going to be 2. And by the way, ordered triple, ordered like the alphabet, x, y, and z, I know that value is 2. Alright, so let's see here. So let's see if we can do this in our head. So this becomes 1y plus 4 times 2 is 8. So 1y plus 8. I'm not doing my head, I'm doing the work over here, and I hope that's in the screen. And it is, just barely. So 1y plus 8, so 1y, we subtract the 8, 1y equals negative 1. Y equals negative 1. Alright, so let's see here. Let's look at this guy. 1x minus 2 times minus 1. This becomes 1y plus 2, remember, because a negative makes this a positive, right? And then plus 3 times 2, that becomes 6, so plus 6. And that's equal to 9. So here I have 1y plus 8. That's equal to 9. I bring over the 8 by subtraction, and then I get 1y equals 1. Not 1y, it's 1x. Come on. 1x. And that means that this x is equal to 1. Okay. So, this is the lesson. This is us solving a 3-variable system using Gaussian elimination. Alright, I promise you on your assignment, no fraction answers. All whole number answers. So if you're getting a fraction, you're doing something wrong. Again, I picked 4 problems I think that are pretty simple. Again, I hope everyone's doing okay out there. A couple more weeks. Hang in there, you're almost there. Have a good weekend, everybody.